Hello, world, and welcome to Decode or Not to Code. I'm Mili Eva. As always, I'm very happy to be here today. And as always, I'm here with Stefan. How are you doing, Stefan?
Oh, my excitement gauge it's peaking. Well, it's almost overflowing. Good thing my environment is implementing arithmetic overflow checks, so I'm fine.
Same here, me too. If you're new to the show, the two of us stream every other week. And if you do not want to miss any of our content, please make sure to follow us on any of these social medias here and also reach out with any questions, comments. Hi, Eric. Welcome to the show. And yeah, Stefan, I do have a question. You know, it's getting warmer, right? The holiday season is coming up. And I'm looking for a lovely book to take to the beach, for example. Do you have any recommendations?
I do, because, well, for this season, we have promised the audience to talk more about benchmarking and about performance and also about what's all related. It all comes down to memory sooner or later. So I have this recommendation, which is quite a heavy book of Pro.NET memory management, which has been authored by Konrad Kokosa, and it is quite heavy. It is also lifting it and reading it also shapes the body to some degree.
Yeah,
which I'm
you get your beach body and your beach book. But Stefan, my friend, you're living in the past because the second edition has been out for almost 6 months now. It's got even more in-depth content, updated insights, and yes, it also doubles as a dumbbell as well. Loads of lovely content. Ooh, it's got my hair in there as well. So yeah, stop living in the past. This is the future.
Yours seems to be thinner than my first edition book. Why is that?
It's because the font is smaller, I think.
Of course. So even more content. That's amazing.
Even more content for sure.
So with all of that content, this looks all quite detailed. And
yeah,
how do we? Could you give me a bit of a stream-sized overview of Pro.NET memory management?
I can do you one better. I can bring in the legends who wrote this. So without any further ado, please welcome Konrad, Christophe, and Kevin. Hello. Welcome to the stream.
Hello.
Hello, everyone.
Now that we have allocated enough space in our live stream here, would you three gentlemen like to introduce yourself? Who would like to start? Maybe Konrad?
Okay, I can start. So, hello everyone. Yes, I'm author of this heavyweight first edition thing that you can definitely get some attention by reading it on the beach, I think. So it happened a few years ago, and I was having a pleasure of making the second edition with Chris and Kevin. They will say whether it was a pleasure or not. From my perspective, it was. So I'm a .NET guy, making .NET for many years, and performance and memory. So that's my nerd interest for many years so far, and having fun doing that.
Wonderful. Thank you so much for joining our show. Christophe, would you like to go next?
Sure. So first, thank you, Konrad, for asking us to be with you on this great adventure. I've been working in the Microsoft ecosystem since the previous millennium, 1990, something like this. So I remember the 16-bit time, but we won't talk about that today. I've been working on .NET since the very beginning because I was in the PDC conference, the Professional Developer Conference in Orlando in 2000, when they introduced .NET, and it was like completely unexpected, and that was very nice. And since that time, I was always playing with the bits, writing my own tool. I think this is what I really love. It's like when I want to understand something to measure, I'm writing my own tool. I hope I will convince you that it's not that complicated, and you should spend some time to integrate some pieces of information in your information pipeline to monitor your application. That's it for me.
Wonderful. Thank you so much, Christophe, for joining our show here. Kevin, would you like to introduce yourself?
Yes. So, hello, I'm Kevin. I'm the second person that Konrad tricked into working on his book. So I have about 20 years of experience in .NET across various stacks. I've done some web, I've done some rich clients, I've done a lot of mobile development when Windows Phone was a thing. And lately, for the last 10 years, I've been focusing on low-level stuff, performance, and debugging. And so I'm mostly the debugging guy, the guy that all my coworkers send the memory dumps when they have a mysterious crash. So yeah, I'm currently working at Datadog with Christophe. And on the side, I'm writing technical articles on my blog, minidum.net, and my pet project right now is writing a GC in C# just to validate everything that I learned while writing the book.
Wow.
So happy to be here.
Exciting. Thank you so much for joining.
Amazing. So here's also the website that I guess still needs to be updated, but we'll post the link into the channel that has also links to purchase the book. I guess still the first edition are linked, but the second edition is out. It's physically available, also digitally available to get your memory management up to pro level. So we would definitely love. We definitely open the stage also for questions from the audience. So if you have any questions to Konrad, Christophe, or Kevin about the book, about memory management in general, please post them into the chat. And I would like to start with the first question about the very first edition of the book, which has been quite influential to me, especially the passage at the beginning where you cite about technical empathy, how a race driver doesn't need to necessarily understand a car to win a race, but it definitely helps in critical situations. So how did you start writing a book about memory management, and how did it become this beast of a over 1,000-page 2 kilo beast?
2 kilo, yeah. The idea, first of all, I always wanted to write a book since the childhood. So I think it was something hidden in me, but I didn't want. For years I didn't know what it should be. So it turned out after many years when I was working in a company in a bank, when I was helping in these performance issues, and I started to get in, and when I started to help, more issues come to me. So I started to learn more, and then more issues, so more knowledge, so more issues, and the loop was closed. So I started to be visible as a guy that is that can help, first of all, and then I was really nerd sniped by this topic. So I think, okay, so if I get this knowledge, and I was also seeing, because obviously there was other books, like a great book from Sasha Goldstein about the performance, the Bible of performance, and others, but they were typically books, very good books, but memory management was a chapter or two there, and I was. There is a lot more that you can cover. Like there, I was definitely seeing this niche. Obviously, that I was super aware that it is a niche, to describe it in more details, because many details were missing, and I was seeing also many caveats and edge cases that I was trying to help and solve, that were covered or maybe not even covered, or maybe covered not in enough details. So I said, okay, so let's write it down, meeting my childhood dreams also. And
Wow.
I started to write, and it happened like 1,000 pages because the topic was so big. Like I really wanted to cover everything. I went wild. Like I really wanted to make something, like everything I know, I wanted to cover. And then also I was thinking I know a lot when I started to write, but when I started to write, I realized how much I don't know, and I then started to investigate and dig in and diagnose and debug the GC and all those edge cases that were also coming at the same time, because I was doing also the consultancy in this area to various companies. So it also kind of a practical hit of those problems at the same time. So I was sometimes literally debugging something for a company and then writing a few pages about something that was related to that, or at least noting down that there is such an issue. So it is a big topic, I think. So that's why in the end it is so big book. And the only thing we could do is to reduce the font, as you said, for the second edition. That was pretty surprising. Like I really remember emails with Apress, the publisher. I said maybe we should reduce the font a little bit because they realized that the book is 1,000 long, and there was even a question that I was included into. They started to discuss whether they are even able to print such a big book. To the technical reasons, how do they make this book? And I was just going to say, come on, I just spent 3 years writing it, so you need to be able to print it. Yeah, but that's the story, I can say.
Wow.
So Pro.NET memory management is the benchmark of presses. Do I get that right?
Yes.
Yeah.
How good they are in printing.
Nice. And I mean, since I've got the second edition here, I guess my first question would be sort of when did you realize that you wanted to make a second edition, and what was the kind of motivation to extend and update it?
Immediately after the publication of the first edition, I know that it needs a second edition. I was just too tired to start working on it. But that's super crazy fast area. So .NET is having new versions every year, and the GC and the memory management is impacted somehow. Maybe not super significantly, but obviously that book was published when .NET 3.1 was in preview. So that sounds pretty ancient for now. So refreshment was inevitable. I was super afraid of doing this refreshment, knowing how much work it is. But then I met Kevin and Christophe. No, I mean, that we probably will cover how we come to that. But having help definitely helped, because it is a tremendous amount of work. But it was inevitable to have at least second edition, because also it was like .NET was not touching this area for many years. Really many years was pretty static, but the last years is crazy fast how much they improve things in terms of performance, and also .NET GC. So it just be needed to be refreshed.
And so maybe how to, like, Kevin and Christophe, like, how did you guys meet? How was this whole for you? Did you read the first edition and then knew you wanted to collaborate, or like what was sort of your story in this?
First, I want to say it's not our fault if the second edition. Okay, don't put that on us. Don't put that on us. Yeah, I can continue. I think like Kevin, we both read the first edition, and we really loved the book because it mixed both high level view that helps you understand what's going on, and then it digs into the details, and you are not lost. And last but not least, for me, it's also about, okay, now that you know that, how could you improve your applications? How could you write better code? How could you write your tool to better understand what's going on? And these are really the three pillars that I really loved in that book. And I think we met Konrad during conferences, if I remember well. So
that was before the release of the first book.
That was before the release of the first book. We met Konrad there, and I have to say that very nice person. when you discuss with a very nice person, very smart person, and after a few years, just contact you saying that, oh, guys, we're thinking about you. Like, I was kind of proud because I was like, why do you think about me to help you on that huge project? And my reason were first that my wife said yes, because I already published one book in 2007, and she said, okay, that was a very nice experience, but never ever again. Do you agree on that? And I said, yes,
Oh
sure,
no.
we agree on that. And so when I get that question from Konrad, I was like, it's very interesting, because I wanted to dig more into the memory management, and I'm working with Kevin at Datadog, and we need to better understand how things are working for profiling, for other reasons. So it was interesting, and the fact that we were free working on that project, and we spent some time at the very beginning to list everything we think might fit into that book, and we look at the list, and we said, okay, and that was a mistake, obviously. But anyway, Kevin, it's your turn.
Yeah, I don't have much to add. When Konrad contacted us for the second edition, this was literally 1 month after the birth of my son. So I almost said no, because it was really not a good time to write it, but Konrad managed to convince me. What helped with that, I've always wanted to write a book about debugging, but I've been hesitant because I wasn't sure about the amount of work needed. And so I decided that helping Konrad on this book would be an easy way to get into book writing and to see if I wanted to do more. I greatly underestimated the amount of work needed just to update this book. So I don't think I'm going to write a book on my own.
So actually, what was the
Wait,
I guess,
for
creative?
wait for 15 years, and you will see.
Well, maybe, there could be like a third edition potentially as well coming up. I mean, who knows? But like, what was actually your creative process? I mean, is it quite different to write like a technical book, or like did you? So I don't know. What was your process? I actually have no idea how to approach something like that.
For the book,
Mhm.
well, I think it would be interesting to ask Konrad for the process for the first edition, because for the second edition we already had the content, so it's really was more about reshaping it and refreshing it. And
Did you
actually,
like distribute different chapters to different people, or like was everybody involved with every single
everybody involved
topic?
with every chapter. Christophe did a lot of the coordination job, because Konrad and myself has the same default, that we like to improvise stuff. And so at first it really wasn't working, and so Christophe took his project manager hat and brought the thing. I didn't read the first edition of the book before we started writing on the second edition, and when I read it,
you realized.
well, I'll be frank, I didn't like it. The content was great, but the writing not so much. The editor I pressed did an awful job reviewing it, and so we ended up dedicating a lot of work just rewriting the content of the first edition. And I'm not saying rewriting from scratch, but rather fixing all the grammatical mistakes and changing the sentences so that they are easier to understand. And just that took a lot of time. So there wasn't that much time left for new content. And for new content, the way we proceeded is we basically brainstormed ideas about what we wanted to add, and then we figured out in what chapters they would go. And then we started reviewing the book from start to finish. And when we got to a chapter when we needed to add new content, we wrote it on the spot.
Can I share my screen?
Yes, please go ahead.
Can I share my screen? Okay, so here is my secret.
Oh.
Our secret. Okay. So
we love sharing secrets.
yes. So do you see my screen?
We do now.
Perfect.
Do you see my screen? Is it big enough? Okay, so I created a project on my repo, and as you can see, it was supposed to be Gosse, Kokosa, Nasarre, the list of the author on the book.
Oh, those letter means. I was always wondering.
Yeah, it was Gosse, Kokosa, Nasarre. So that was the list of the author we were expecting in the book. If you look at the page that you've already shared, you've seen that it was changed to Kokosa, Gosse, and me. And then when the book was published, it was another different order. So it's like magical. But to answer your question in a little bit more detail, we created issues. Is it like closed? So we created a lot of issues corresponding to everything that could be added, where it should be added, in which chapters, with each time put it as much as information as possible. This one is not really detailed, but others are very, very detailed. So that was the second part of the work. As Kevin mentioned, we agreed since day one with Konrad that as a reader we would change some of the way things were explained. And Konrad was very open with that, and thank you for that, Konrad. He also explained to us that he got feedback about, like, it's good, but sometimes it's a little bit too long or something like this. So we spent, as Kevin said, a lot of time working on trying to. Whoops, this is too soon. Trying to streamline the explanation. We also wanted to remove some content that would not make sense. And an example of that is before .NET Core 3. something, the Linux support was like very, very, very poor. And so we decided to remove that content and make it available as free PDF download. So if you go to the website of the book that you've provided, you will get the link to download freely that part that we removed from the book. And obviously we put in place the new way to get information on Linux with much more tooling, much more use cases. And I think there was also at the beginning some very historical view of memory management that, from our perspective, was a little bit hard for readers that bought a book about .NET memory to spend like 200 pages, or no, I'm exaggerating, but like a lot of pages, like 50 pages or 40 pages about historical stuff. And again, we did that job of removing that part from the book, but again, making it available as free PDFs. And again, the same idea is to have a more streamlined way of presenting information. So nothing was removed. Okay, so you can get the exact same content, but we updated the content to make it exact for the new features, and keeping the old And one of the examples was the fact that they are using regions now to manage memory, pieces of memory, chunk of memory. And we didn't remove the segment part, which was the original one and the one that is still there for .NET Framework. So yeah, if it answers your question, it's like we did this huge preparation ahead of time that helped us agree on the fact that that could be done. Then we decided who should focus on some of the area. We could be two focusing on the same area. And we updated the chapter when the chapter was like ready to be reviewed. We spent hours of time nitpicking on wording, on samples, on everything, because the three of us, we really wanted to have something that fits the feedback that Konrad got from the book, the feedback that we got as a reader. And we really hope, I'm crossing fingers, that the reader of this edition will find it useful for the reason I've already.
Yeah, I can also add a few words about the first edition, like how it was to plan the structure of all of it. And I must say I spent literally weeks planning the structure. And if everyone wants to write, it's not so relevant probably, but if anyone wants to write a technical book ever, I strongly invite you to do the same. Like I was literally, we have a new guest.
Kevin too, the second.
Yeah. The third edition author.
Yeah. The second
edition. It was
1
month when we started writing the second edition. Now he's 2 years.
Yeah, that sounds how fast it was. Yeah. I think he should be at least author of the third edition. So just going back to the topic. So the idea was to literally make sticky notes about every, even the more detailed topic you want to cover in a book. Throw it on a wall in a form of digital wall, and start to reorganize it in a way that creates a flow of concepts that you want to explain. So what should be explained before what, in what groups you want to group it, and how, and then the flow of the book is arising out of that. So it was. I think I have even this somewhere posted. The big wall of sticky concepts, sticky notes with concepts that I want to introduce, and how do they group, and how they should be, what should be the order. I think that's definitely the best approach in writing a technical book.
I think that's something about pulling.
So there is
your mic is somehow.
Yeah.
I'm sorry. I think my Wi-Fi is very bad. What I wanted to add is,
I'm afraid we barely understand you. It's like you're talking through.
You're underwater.
Yeah.
To move outside of the water. Yeah. What I wanted to say was about tooling that we didn't expect at the beginning, and that thing was like, it should be easy to write with 6 ends, because we have 6 ends working on something. So which tool should we use? So we tried some stuff at the beginning with Markdown, if I remember well, Konrad, and it was not very successful. Then we tried other thing, and I said, yeah, we should use Word, and okay, I would say it was the least worst tool to use. So we got some problems, we got some merging issues, but at the end,
yeah.
Are you sure you don't have something on top of the mic, or
it sounds like someone
noise cancellation? I don't know.
I can remove my stuff and just work with my laptop.
Take your laptop, maybe.
Like that. Taking my laptop. Okay, let's do this. So now you hear me. You're not hearing me anymore.
But I guess
in the meantime, I can add.
Maybe I can.
You know,
also
restarting something will help.
Is it better now?
Yep.
Yes.
Yes.
It's
Woohoo!
better now. Okay. Because it's usually like this with Kevin. Okay, I'm preparing everything, rehearse like 4 hours, and he said, "Oh, it's 2 minutes before the beginning. Could you change your sound?" And I'm like, "What?" But it worked this time. Nice try, Kevin. Nice try. Sorry about that.
Yeah, and I guess, Konrad, I've never written anything, but I can kind of imagine that you kind of feel a little bit also like protective. It's your work. You put 3 years into it, obviously. What was it like for you to obviously, I mean, you said you were kind of hoping for the collaboration and reached out, but what was it actually like for you to sort of open this space up and really also give away a little bit of the I guess responsibility, but it's kind of like, your first publication.
First child to give
Yeah,
up.
a little bit, right?
I must say that I was having absolutely no problem with that, considering that it was Kevin and Christophe. We know each other. We are just, I think we like each other, and it's not on the nerdy technical level, but just it clicks. So it was really no brainer. But
Nice.
I can imagine it could be a problem if it will be some kind of an author that is unknown to me or something like that. But it was not an issue here. So I was definitely. No, I must say I haven't thought about it even once. So.
Wow, that's amazing. That sounds like a great collaboration. Well done.
Speaking about collaboration, well, first of all, Laszlo is on the stream, and I think he's already giving some feedback to the book on social media. First of all, Laszlo says it's an excellent book and it has great updates. The second edition. He's also mentioning, I think, also a little bit on social media, that there are still some x86 related paragraphs in the book, also some older maybe large object heaps, topics. So how is the impact of the community when it comes writing a book, especially a second edition and maybe errata and all of that?
Who will answer now?
Who would like to share their thoughts?
Like I can say, I think I was not taking into account some very specific feedbacks in particular, but more the spirit of the feedback from various people that I've met, saying that it is like too heavy, too big. But in general, I think we are somehow tuned with the potential reader of this book. We know, I think we kind of feel what the reader expects. And I was personally feeling I know what should be improved, even without super going to outside and asking people. But still, having Christophe and Kevin was extending this feedback because they have their own, people that they talk to and the feedback they gathered. And I think that was that way. We didn't open any forum community with Discord server to discuss creating the second edition. But I think this feedback is somewhere there, right?
I would say that you've also did a lot of stream presentation. I don't remember, I mean, like 12 sessions, something like this, almost one per or maybe more than that. And you got a lot of questions at that time that I remember. And that was part of the feedback that was interesting. The other thing also that we looked at are the issues in the CLR repo. When you look at all the issues since .NET Core 3.1, you can start off, look at what makes sense for people and try to focus on that. But yeah, we also try to share some of the writing process and reviewing process. I think we did once or twice, I don't remember, where we just shared this kind of, okay, let's discuss that chapter and for the feedback. But I don't remember that we get so many feedbacks. I mean, specific feedbacks for topics, and I don't think we missed a lot. Based on the comment that you've read, maybe we've left a few stuff that were like 32-bit specific case, but we tried to check everything. What I mean by that, I mean that we wrote all the single piece of code, a line of code, to validate that what we were saying, what we were writing was true at the time we wrote the book. So we hope, I mean, we always leave typos, mistakes, stuff like this, but we really try to avoid that by again writing a lot of code. We wrote a lot of code for this book too.
Speaking about code, from question of the audience, will you guys write a post or book how to profile applications, memory checks, object allocations, and GC calls? Do I get it wrong? Is this not all covered in that book? Could you perhaps give us a bit of an overview of how the GC works? How do we allocate applications? Because I think the book also mentions in some programming languages, it is considered too crucial to leave the memory allocations or memory management to the user. In some languages, it's too crucial to keep it to the machine. So how is .NET going about this? How does GC work? Memory? Perhaps could give a bit of a 10,000 foot view.
I can start. The 10,000 view is you allocate and then you don't care. Konrad will explain the rest.
Then DC kicks in and cleans the things up. Kevin, please fill the rest.
To be fair, we didn't cover the profiling aspect specifically. We did say how to measure the performance regarding the GC specifically using .NET counters, but we didn't cover the profiling part. Yes,
I have written a few blog posts about that.
Yeah.
So if you are interested in that, I have written a lot of blog posts that explain how to get this kind of information and the different ways to get this information. I've planned to do some demos at some point that will show you the tool that you could use and the kind of code that you could use in your own application. I'm working in the profiling team of Datadog, and I'm writing the profiler for .NET there. So I've published a blog post on the Datadog engineering blog post, the Datadog engineering blog, where I explain how all our profiling are working in great detail. So between that one and my personal one, I think you would get all the different ways to get that, plus the source code that we share, because the Datadog profiler is open source, and all the source code in my articles are available on my GitHub repo. And I think same for you, Kevin. All the stuff that you explain, it's available on your GitHub repo.
Yeah, that's correct.
And by the way, profiling, there is no good about profiling. Maybe you should write pro.NET profiling. Like there are memory bound problems and CPU bound problems. This book is about memory bound problems, but CPU bound things also probably exist in .NET. We could like profiling things, GIS and things like that. Yeah, that's an interesting topic. We don't cover obviously that in that book, but maybe if someone wants to write a book, I will read it.
Yeah, I think you have some hints with Watson, Ben Watson book.
Yes, obviously we have product and benchmarking from Andrew also.
Yeah. The term profiling.
This one, right?
the next guest.
That was great.
Yeah. There's another one like writing
you're spoiling future
performance.
episodes.
Writing performance book and also the one that you mentioned earlier, Konrad. But the point I wanted to make was like profiling is misleading. The word profiling is misleading because when you talk to a developer and you say profiling, most of the people are thinking about CPU profiling. You want to measure how many milliseconds you spend on the core, and it's only part of the possible reason why your application is too slow, or the latency of your request processing is take longer than expected. It's only part of the picture. And to answer your initial question about how the GC is working and stuff like this, one of the side effects of allocating a lot of memory is that you will trigger more garbage collections, and there is no magic. The GC must have threads running at some point to do. For me, it's the tip of the iceberg. It's like a symptom more than what should be done to avoid that.
Fair enough.
Speaking about memory, and maybe this ties in a little bit to a question from Laszlo, while still reading the book, wondering how regions and the order impact the overall planning phase and such. I believe there is a tool that you wrote, I think Kevin did, about how to visualize how memory is allocated and then maybe also deallocated again. Could we take a look at this, and perhaps so that we get a bit of an understanding of what the GC is doing for us?
Yeah, I don't think that would answer the question, but that's a great transition. Well, first to address the question, how the order of the regions impact the planning phase? Well, the short answer is it doesn't, like at all, and that's also the long answer. I feel like you probably have a preconception that is wrong. If you could ask a follow-up question about why you are thinking it would have an impact, then maybe we can help clarifying some points. So yeah, I developed a tool while writing the book to visualize the way the GC organize the memory, mainly because it helped me while writing the book. It helped me understand how everything works and then to put it on paper. Because yeah, I'm the kind of learner that need to do the stuff to actually learn it. And so I can demonstrate it quickly if you want.
Yes, please.
Yeah.
I'm starting to share your screen.
Yeah. And so I just created a quick sample application just so we have something to observe. So it's a console application. It has a bag just to store memory, to keep references to objects. And then it's an infinite loop. And if we tap a number like 6, it will allocate 6 megabytes in memory. And it can do it 2 ways, either in small chunks or in one single big allocation, in which case it is going to go into the large object heap. I also have a command to clear what we allocated. And every time we enter a command, it's going to do a garbage collection. Unless I tap compact, in this case, it will force compacting garbage collection. Otherwise, it will let the GC decide what it wants to do. And so I start my application, GummyCat, and I start my console. There we go. And so GummyCat needs to be attached to a target process and can also work on a memory dump. So I attach to the process, and immediately we see a representation of the memory. And so there is an example at the bottom, but basically in red, well, in pink is pinned object heap. And then we have generation 2, 1, 0, and the large objective. And so those are individual regions. Basic region have 4 megabytes. Every square is 1 megabyte, and so on. And there is I built this view because I really like defragmentation tool and a bit nostalgic, and so I wanted it to look alike. But there is the logical view, which is, I would say, more useful and more easy to understand. Anyway, right now, nothing is happening. I haven't allocated any object. And so the way it works is that GummyCat will listen to garbage collections, and after each garbage collection is going to scan the model. So it's not live. And that's why every time I allocate an object, I force a garbage collection. And so if I allocate 1 megabyte, so we've seen some weird stuff. And so so the two record what's happening, so we can go back in time. So that's what we had initially. And when I allocated and forced a garbage collection, we can see that the GC allocated a new region at the end and deallocated this one, which is really weird, and I have no idea why it's doing that. And so if I allocate a bunch of, there we go. Okay, I'm just allocating a bunch to show. And so I need to put post. And so every one of those regions can store 4 megabytes. But you can see that every time it's creating a new region with just 1 megabyte. And when I force a collection, it's going to promote it to a different generation. So for instance, if I look at this region, right now it's generation 0. I force a garbage collection, it becomes generation 1. And I force another garbage collection, it becomes generation 2. And we can see that the GC decides to have all those regions that are barely filled. They contain just 1 megabyte out of 4 megabytes of size. So it doesn't have to move objects in memory, which would be costly. And that's something that regions allow to do. Because in previous version of .NET, when we have segments are pretty big, like 1 gigabyte. And so the GC can't just decide to leave a segment almost empty and create a new one. And it has to move objects around to store them inside of a single segment. Whereas with regions, it can decide to leave them half empty to avoid having to move memory around. And so I'm going to pick a bunch more. And then at some point, I can decide to force a compacting garbage collection. And now the GC is going to move objects and merge regions together to compact the memory and reduce the working set. If I do compact, we see that before we had all those regions, and after compaction, we have just a few. I don't know if it's easy to see on the stream, but there is a darker area that indicates the filling level of the region. And so before we can see that they are almost empty, and after compacting, the GC tries to fill the regions as much as possible. And so so this is the goal of this tool. I just want to show one last oddity before stopping. So this was with workstation GC, so I'm going to enable server GC. And there is this feature that is named data for dynamically adapting to application size. So by default, there is one region by one heap by CPU core when running in server GC. So I have a pretty beefy CPU
wow.
with 16 cores, and so it means that the GC would create 32 heaps by default. And when you are running with a small application, this is a waste of resources because you probably don't need that many heaps. And so this new feature allows the GC to dynamically adjust the number of heaps depending on the workload of your application, which really helps bringing the memory usage down. And so there is this odd thing. I actually never reported it to the runtime team, and I probably should because it might be a bug. And so here it's the application as startup before any garbage collection. And we see something weird in that the GC is reporting that it has only one heap. But when you go into the details, it's easier to see with the logical view. There are regions created for each of the 16 or 32 heaps, even though they shouldn't be here. And it's more apparent with the large region because there is one per heap. And if I allocate just 1 megabyte, no matter what, when we get after the first garbage collection, then the GC realizes that it has all those regions that shouldn't exist, and it clears them all at once. And from this point onward, it's going to behave normally. And I'm fairly sure that this is not expected, and nobody noticed it because it only happens before the first garbage collection. And I would say it really demonstrates the point of this tool to understand how the garbage collector work. Yeah, and that's all I have to say about this tool.
Just to chime in, it's not only the first bug or thing that was reported by Kevin by writing on the book. GC's had some things to be reported.
Yeah. In the process of writing the book, I found five bugs in the garbage collector that we reported. Precisely because every time we learn the new stuff, we try to verify it. Often we realize that things are not working as they should. Because the GC is pretty big and pretty complex, and I think even the runtime team is struggling to test it properly.
We should have
not only for the readers, but it's for the whole .NET ecosystem, improving the GC.
Yeah. Oh wow! So the book also has runtime impact. I see, not just educational. I'm wondering, for this tool, are you exclusively using the system.gc APIs, or are you taking a deeper look into the system, into the process?
Yeah. So I'm actually using two different APIs. Let me remember. So GC is publishing events through event pipes, and you can listen to event pipes using a library that is publicly available. And Christophe wrote a lot of articles on this, so if you want to learn more, go read his blog. And so I use this to know when there is a new garbage collection, and whenever there is one, then I use CLRMD, which is a library that allows you to inspect either a live process or memory dump. I use CLRMD to attach to the target application, and then I pause the application and I scan the memory. And so there are those two different mechanisms. The one drawback of this is both mechanisms are asynchronous. And so if you have like a garbage collection every few seconds, then it will work well. But if you have multiple garbage collection in 1 second, then by the time I receive the notification and I scan the memory, then the memory layout of your application maybe has changed a lot. And so this is not great. So unfortunately, the tool is not suited for application with a big workload.
All right.
And if you are interested in learning more, the tool is open source, so you can check the code.
Nice. I was wondering about something you said earlier about this this compacting phase, why do we want to avoid moving memory around there? Does that make sense?
Why do we want to avoid that? Because it's costly. I'm trying to think about how deep we want to go, but when in a world where you don't move objects, so you don't do a compacting GC, you only do what we call a sweep. You can collect memory almost entirely without pausing the application. In .NET, this is done by the concurrent garbage collector. And so you can read the detail in the book. It has to pause the application 2 times, but very briefly for some bookkeeping. But mostly it happens concurrently with the application. And so it has a very low impact. But unfortunately, this is going to fragment the address space. And so at some point, you have to do a compacting collection to defragment the memory and reclaim all this free space. And because the compacting GC is going to move objects, so first it's going to have a higher overhead because you are adding some memory traffic. And more importantly, it means that the GC will have to rewrite all the pointers that point to the objects that are moved in memory, which means freezing the application for a much longer period of time, and so having a bigger impact.
Fair enough.
I think I now begin to understand. Yeah, so the managed heap we don't need to care about. But if I have a pointer, I'm always told, well, you need to pin it or get this pinned thing, and to fix it. Is this now tying into the pinned to the pinned segments of the GC, or am I mixing things up there?
Christophe, I feel like you want to take this one.
No, but I will take it. No. Pinning memory comes from the old days. Maybe this is why you mentioned that it should be me to talk about that. I'm the old one. At the very beginning, .NET did not provide all API in a managed way, and you can imagine that they need to. For .NET Framework, call function from native, like kernel 32, stuff like this. And in that case, you pass pointers to structures or to pass information, or you pass pointers to buffers where the native function will write the information to come back. But if you follow what Kevin explained to you, when there is a compaction, the object that you created there in memory after a compacting GC might end up being there. But unfortunately, the native code received the address of the first here. So the native will look at this. And the information that is supposed to be there to write the answer is no more there. So you will overwrite something that is completely unrelated. So this is not working. So there was a mechanism put in place by the runtime that allows you to allocate an object and say to the GC, please don't move it if there is a compacting garbage collection. So that's the old way to do it, and the new way is what is shown by this GummyCat tool with the very nice pink rectangle. And what they said, okay, instead of doing this in 2 steps, like I'm allocating, so when you allocate, it ends up usually in Gen 0, because Gen 0 is called 0 because it didn't have any GC happening there. And after that, you pin. So you will end up with having like pinned object in memory. I have a demo about that. So they did to offer an API to allocate an object, and it's usually an array of bytes, an array of stuff, in a specific heap called the pinned object heap. And this pinned object heap is not taken into account by a garbage collection. So it knows that the objects that are there, they don't compact there, okay? They keep track of the empty when they are no more used. But that's pretty much it. These are the two ways to get pinned objects. It's for native interop.
So I can directly allocate on the pinned heap, but I can also pin a reference on the other heaps as well.
Yes,
which may not be as efficient because it's still in that managed heap, but if I use
it's still a managed heap. It's still okay. Usually when we say a managed heap, we think about a heap where we put managed object. Okay, but you have another one. Is it visible there? Yeah, it's called the frozen heap. That's the name you've given, Kevin. That the dark gray one, and that's the old name. And if you look at some documentation, you will see frozen heap, but now it's called the non-GC heap. So the non-GC heap is a managed heap where you can put managed object, but it's not managed by the garbage collector. Okay, I don't want to dig too much into that stuff because
naming is one of the hardest things in.
But think about let's take just one single example. If you need to put somewhere in memory object that will never change and that will never die, it could be good to put them in some places. They don't need to be pinned, but at least they stay. And one good example is every string that you write in your C# code, like console.writeLine hello world, the hello world string will end up into that specific heap once it's get allocated. So we have many more managed heap now, even managed heap that are not managed. That's the joke of the day. I'm sorry. That's I can't do better.
I see. We also briefly mentioned the different GC modes. So we have a question from the audience. What are the difference between workstation and server GC modes, and when should we choose which?
Okay, I will pick that one after you talking. So there is always a problem of having one tool that fits all, and there is a really problematic to make a GC that fits every possible workflow of your application that you can imagine, an environment in which your application works. So various ecosystems are doing that in different ways. Like, for example, in JVM, you can have multiple GCs that are for various scenarios, and those GCs also have dozens of flags that you can tune to tune to your specific use case. And the same approach is in GC, maybe on the higher level. So one of those highest levels is this distinction between the server and workstation. They are just for different apps. Server GC is something that will be for request processing when the throughput is the most important, and also when you assume that your machine is mostly your own, so you can consume as many resources as much as possible. You don't care, simply you are the app on the machine and you can just utilize it to the maximum extent, or at least be pretty aggressive in consuming this machine. And the workstation will be all around the different type of application, which is interactive applications. So their responsiveness is the most important. The short pauses, and also not consuming too much, because it's assumed to be just a kind of a desktop app that is just living on your machine all together with many other apps. So it should not consume as much memory, all memory on the process, because it's just one of the apps on the machine. So in being responsive and being pretty good citizen of the ecosystem to not consume too much resources, that would be the workstation. And this is one of the main flags that you can control. Obviously, there are many others. All of that is mostly around aggressiveness of consumption of the resources, and also so in terms both of memory usage and CPU usage, and also in the end how much, like whether you mostly care about throughput, So processing a lot of requests per second, that would be your measure that you look at, or maybe short pauses, so not having any interruptions. Yeah, I think that's the main distinction.
Cool. And I guess we also have maybe the follow-up, the clarifying question from earlier when it comes to the out-of-order regions. I believe it does. Can Gen 2, Gen 1, and Gen 0 regions happen out of order in memory? For example, if regions are laid out as Gen 0, Gen 1, or Gen 0, then a Gen 0 region, would it complicate offset calculations during planning a Gen 1 collection in that case?
No. So there are multiple things to consider. The first one is that even without regions, the GC can have multiple segments, and so that's something it had to do anyway. The reason why it doesn't make it more complicated is because the granularity of the offset is smaller than the region. Basically, I'm not going to go into the details, but the GC is going to divide the memory into plugs and gaps, what we call. Plugs are a group of objects, and gaps is a group of free space between plugs. The algorithm is explained in detail to the book. And so you have to adjust this offset at the granularity level of your plug, and you have multiple plugs into the same region. And that's why having multiple regions, even out of order, is not going to make this part in particular more complex.
Mm-hmm.
And it's also part of the benefits of having this small compared to the big segment, because the regions could be reused. What I mean by that, region that was 0 might be used as 1 or something like this. There is, because before that you had like the segment, you have this ephemeral segment that contain the Gen 0 and the Gen 1 and the Gen 2 and a lot of Gen 2. Now it's like more generic, and the GC could have more generic ways to reuse, to use regions that have the same size, so they can like change something like this.
So we see that GC does a lot of stuff automatically. Now, we have a question from Eric. Would we ever take the opportunity to disrupt the GC and force it to run, for example, when waiting for I/O?
I'm not sure why triggering a GC while waiting for I/O would make sense. Okay. I will phrase it in another way. When you read the documentation of the memory management, you will.
That's a suspension.
I've lost. Okay, you see, I've said something and everything should trigger a GC.
I'm pretty sure it was insightful.
Yeah, I try to mimic Gandalf, but I'm not good at this. So what I want to say is that the document mentioned that you should not call GC.collect, something like this. And the reason that is given is like it will mess up with the statistics inside the GC that changed his algorithm and stuff like this. From my perspective, the main reason is as both Kevin and Konrad mentioned, when you trigger a GC, especially a Gen 2 GC, it will take time, it will consume CPU, it will suspend your threads. So one of the two use cases where I think it could be interesting to use GC.collect is one when you are in a desktop application, and for example you have worked on a document and you've closed the document. You know that at that time a lot of memory won't be used anymore. And the user is expecting that when you close something, before it starts doing something else, the time that you spend there is not really seen as a big stop. The second thing is when you are looking for memory leaks, you need to ensure that what stays in memory is really what is referenced in memory. But I won't go into the memory leak workflow, but that's the two examples I have in mind that could be used.
I will just one thing. It's tempting to think that my application is waiting, so why not do a GC? But doing a GC too often has other drawbacks than just CPU usage during the collection. The problem is that the objects that survive are going to be promoted to Gen 1 and Gen 2. And so they are going to stay alive longer because then they will have to wait for Gen 1 or Gen 2 collection. And so by taking advantages of these pauses to run the GC more often, you are going to cause objects that would normally have died in Gen 0 to be promoted in other generation. And in a counterintuitive way, you can be actually increasing the working set of your application. So it's really hard to be smarter than the GC.
Fair enough.
We tried, but we failed.
Thousands of calls.
I actually have another quick question just about the tool, and that's really fabulous work, by the way. Congratulations. But why is it called GummyCat? Where does the name come from?
Because that's the real signification of the GC abbreviation. Yeah,
GC.
I love it. That's great.
And Kevin and myself are cat people.
Same here. Great.
That's the real name of GC. It's not garbage collector. It's GummyCat.
No.
GummyCat.
We had to tell the world. Thank you for that, Kevin.
Awesome. Well, thank you so much, Kevin, for sharing the screen and showing us that. I guess we also have a couple of slides next, don't we? Is that right?
Perhaps, Christophe, would you like to share your screen, and can we? The transition may not be perfect, but
oh, no problem. What I wanted to present is something that I truly believe in. It's the fact that even if most of the thing that we are showing looks like sorcery or magic, it's not, okay? It's not. It requires a lot of work to build it's some code updating data structure. And it's really like this. So what I want to show you is that you can use tools to better understand what's going on. And Kevin showed you one that very dynamically, very visually shows you how the GC evolves over time. And you can use another one, which is called VMMap from sysinternals. And this is this tool, sysinternals. And if you look at one process, and I have one tiny tool that I will show you after that, which is the .NET Heap Viewer. I will show you after that. This is a .NET application, and I want to select it. As you can see, GummyCat, it's much easier to select the process. And despite the ugly color that has been chosen here, I won't talk about all the lines, but the line that is interesting is this ugly green line, and this green line shows you the content of the .NET heap. So the .NET heap is built on a lot of native part. All this stuff is related to native part where structure inside the CLR are stored. We don't really care about that. The one that is interesting is this one, the GC. The GC one is the one where you see in the address space. So really in the address space where the different regions that Kevin mentioned up here, that you have the pin objective, you have the Gen 1, you have the Gen 0, the Gen 0, the large objective, the Gen 2, and he mentioned the Gen 0, the Gen 2, they are like 4 megabyte large, and the large objective is a little bit bigger than that. Sorry, large. I need to click on the right. So here you have the place in the address space where all these different blocks are stored, and it could be interesting to see. I don't want to dig into that, but usually when you are working with containers, you have like limitation in terms of memory. And when we say memory, we could mean, I would say, like 10 different things. But here it's mostly the working set that looks like the RSS on Linux. And for Windows, the working set is the amount of memory that is in real memory. So the address space is the virtual memory, something that it's like very, very, very big. But the committed memory is the memory that you use from this address space, and that committed memory could be either in your chip on your laptop, or it could be saved on disk, like swapped on disk. And this is where you have the size of the memory that is really seen maybe by your memory manager at your container level to understand where stuff gets stored. The also interesting part is that as you've seen with the GummyCat, where Kevin shows you that in a block there is a darker side, but you also have one side which is like free. It's not free for the operating system. It's free for .NET, but it's still committed. So it still has a price to pay for the operating system. So that's what I wanted to show you with VMMap. Second, the thing that I want to show you, and this one I think I will jump. Okay, so I'm usually the cat, and Kevin is the red panda, and you can imagine that I didn't design that graphic. Kevin designed it for me. Thank you for that, Kevin. I don't want to spend some time here, but we talk about how things are working. We are talking about customization with the workstation or a server, but you also have other settings, or I think they call it knobs. So kind of customization of the garbage collection. And one of the customization that could have a big impact on your application is the threshold used by the GC to figure out if your allocation should end up into the large objective or not. This is the question that you get in almost each interview, which is, what is the threshold to decide when an object goes into the large objective or not? And almost everyone knows that, okay, it's 85,000 bytes. And if it's bigger than that, then it ends up into the large objective, blah, blah, blah. But the main difference between the large objective and Gen 0, Gen 1, Gen 2 is the fact that the large objective is very, very rarely compacted. And so you might end up into having a lot of region and stuff allocated by the GC just to keep track of all your big objects. So what you could do is increase the size of the threshold. And this is a very simple example that looks like what Kevin showed you. This function allocate big objects that are supposed to be bigger than the threshold. If you keep them as it is, you can see the result, and the result is like the duration of that loop is like 1 second, and you have more than 2,700 garbage collections, which is huge. And if you just change the size of the threshold, you can change the size only to make it bigger. Okay, you can't make it smaller. So you can make it bigger, and then you can see that the effect is just insanely large, because it means that all these temporary objects, all these array of bytes are temporary. They trigger small Gen 0 garbage collection. So one more real life scenario is like, imagine that your web application receive a big payload. That payload might be bigger than these 85,000 bytes. You would enter into this kind of scenario. The opposite also, if your answer that you want to send back is bigger than 85,000 bytes, you might end up into that kind of situation. So my recommendation would be measure what you get and what you send back, and see if just by changing the threshold, you might get much better performance. And I know that that Kevin has a strong opinion about the large object heap. And if you want to say your opinion, Kevin?
Yeah, my opinion is a bit easier to apply than Christophe is. Don't bother with the LOH. I've never once seen it improve the performance of an application. So just set the threshold to the maximum, which is 4 megabytes, and stop thinking about it.
Yeah, thank you very much, Kevin, for this very strong opinion. And, but it's something that we don't realize. We should try to optimize our application, and sometimes it's just by configuring the runtime. And this is one of the kind of configuration that could really help. And remember that threshold, the value of that threshold, about 85,000 bytes it's really like built in before 2000. So things have changed so drastically that probably that really makes sense. Okay, so POH, I mentioned. Yeah, okay, again, I'm the poor cat. And okay, again. So for this pinned object heap, I already mentioned that you could allocate, and the name of the API is gc.allocateArray to pre-allocate. And what I wanted to show you is that you can use CLRMD to write this kind of tool where you load a memory dump, or you attach to a running process, and you can see what's inside the different kind of generation. And here, what I want to show you is that all the tiny, if you can see it, all the tiny white vertical lines are the free space, and the red lines are the pinned objects. So if you think about, let's say I want to compact that application at that time, this tiny how can I do that? Can I do? I don't have my mouse, but the one see says that to be moved. So all that's memory from that to the beginning, even if you have so many empty space, will still stay there. Okay, the memory can't be reclaimed by the operating system. You can't give it back to the operating system. So that's not very good. Not very good. So again, you can write this tool. This tool is the source code is available. Measure. Look at what you've done and what is the effect of your code, and that's very good. The last thing I want to show you is how to monitor the garbage collection. You have this purview tool that everyone uses. That is pretty complicated to use, and I recommend that you look at the documentation written by Mauni Stevens, the lead dev of the GC, that had a very long, very detailed document on her GitHub repo that explain how to use the tool to do the investigation. So I won't dig into that. What I want to show you is that you can use other tools that might fit better for your scenario, because Purview, basically you record a session and then you analyze the session after that. But if you want to see what's happening live, you could use different tools. You could use .NET GCMon, written by Mauni Stevens, that provide the same kind of information that you get for Purview. You could use this .NET GC stat that I wrote that tries to focus more on explaining the reason of the garbage collection. You can write your own tool directly in your source code. And that could be something interesting, like you could emit metrics that you add into your data pipeline to monitor your application. And what I want to show you is exactly that. So here I have an application that is using this dead GC memory information, which correspond to what you get in Purview, plus the total pause duration. Remember, as Kevin mentioned, even for server GC, background GC, you have some specific time, like twice, where the threads get suspended, and you want to measure that suspension time. This is what this application will be doing. So the other one is the one from Maoni. No, this is mine. So I need to get the process. Sorry for the setup. I wanted to do that live. And then I have the last one, the one from Maoni. And for one from Maoni, you can select which column you want. And then this one will trigger a garbage collection, and you will get some information. So the one on the left is the kind of information that you get in your source code. That you have like almost everything. You have all the memory that gets promoted, all the fragmentation, the pinned objects. You get the pause time. You see it's like very few microseconds. The size before and after for each generation. Here you get the which generation was collected with kind of flags. So it was a compacted one. It was a fourth GC. And here I'm just allocating a little bit like what Kevin was doing. And you will see that the garbage collection will be triggered. You get information. This one was a concurrent one for Gen 2 and so on. So it's another way a more textual way. But when you want to monitor your application over time, you can collect this kind of information and use it inside your own metrics solution. So my takeaway here is you have plenty of API, and believe me, they are not complicated to use, and it will help you monitor your application and better understand how to improve their behavior. And that's what I wanted to share with you.
Cool, thank you very much. We had a question if Purview was outdated. I guess it is not.
No.
To another...
no, it's not. They are continuing to work on them. And I have discovered some specific views that are not even visible if you don't recompile or if you don't pass any specific flags, and some memory related pages. So yeah, no, it's not that.
No.
It's still white and yellow. Yes.
And it just looks like outdated, but it is not.
It is not.
But if you want to investigate your GC, then Purview is still the best tool. But if you are more looking into CPU profiling, then there are much better tools out there. So
yes, you have dot trace.
Yeah.
Dot
trace, superluminal.
Superluminal is if you combine both native and managed profiling. I think Kevin and myself bought a license. It's like with my own money, because that's the best profiler here. And I'm not working for Superluminal, okay? I'm not
yet.
I'm working
Yet, exactly.
Yet, I'm not. Yet. Thank you for the secret.
So has somebody thought about creating a model context protocol for Purview to make it LLMable?
This one is for Konrad, I think.
Yes. Well, sounds like a fun project, definitely. Diagnose and then fix. I think someone will do it eventually. Obviously, the thing is, it is very specific niche knowledge needed to LLM to be able to make sensible, actionable things in Purview. So exposing Purview via MCP is one thing. How good LLM would be to use it is another. But that times will come for sure. So we will see.
I was frozen again. Sorry about that. What I can say is internally at Datadog, we are working on this kind of subject. What I mean by this kind of subject is we collect gazillions of stack traces like Purview does. We have identified a few anti-patterns that, if we look at the call stack, will be like jumping in front of our eyes, and we try to make the link between the two, so that automatically the LLM will be able to say, maybe this is a sync over async kind of pattern that you've done. Maybe you should change that call in that specific part of your code. But don't tell anyone, okay? That's the secret.
No. We earlier also had a statement about, now imagine if .NET had multiple GCs as the JVM does, which now leads me to the question to Kevin, since I reading your blog post only, well, it's challenging me. So you're writing your custom garbage collector, and I'm wondering, how did you get about writing a custom GC, and what lessons, what takeaways did you take from him? Actually, you're writing it in C#, which also surprised me. I thought this was also possible.
Yeah, well, I explained at the very beginning that I need to build stuff to properly understand them. And so ever since I started working on the book, I wanted to try writing a GC. But writing it in C++ is very annoying, because it's already a very complex topic, and then you have also to fight against the language itself. In fact, I think Konrad went through exactly the same process, because after the first edition of the book, he started writing a GC in C++, and then he gave up. And I suspect that, I'm not going to talk for Konrad, but I suspect the language is a large part on why he eventually gave up.
No.
So yeah, and I've been playing a lot with native AOT, which allows you to compile your .NET application into a native application, which allows you to use .NET in scenarios where it wasn't possible before. And so I realized that I could use it to finally write a GC in C#. So that's what I started doing, as you can see in my articles. So I've started implementing the mark phase. So the mark phase is the beginning of a garbage collection, when the GC browse all the objects in memory to determine which ones are still referenced, and so which ones can be collected. And yeah, not sure what more to say about it.
This is one of those crazy fun projects that maybe fail, maybe not, but even the journey is fun, right?
Yeah.
Yeah,
Kevin,
definitely.
I have a question for you.
Yeah.
Do you think that the API or the interface that are required to write such a GC is like forces you to follow the choices made by the CLR? And if we go back to the question about like JVM, the JVM, they have like plenty of different GCs with different IDs that even maybe generation doesn't make sense, or they have other way to optimize memory access. Would it be possible with the current state, even in C#?
I feel like you almost answered your own question. So what Christophe was alluding to is that the GC API in .NET is not really the GC API, and it's more an abstraction on top of the existing GC. And so, and that's something I mentioned in my blog articles. If you start writing a GC using this API, you have to stick to some important design choices that were made for the .NET GC, because they are enforced by the API. And so if tomorrow somebody wanted to actually write a production-ready garbage collector that works differently from the .NET GC one. For instance, a low latency GC. The best part would be to fork the .NET runtime rather than trying to use the GC API.
Okay. I guess I also saw we had another question from the audience that's kind of relating, going a little bit away from that, a little bit more to the book. So maybe that's something for Konrad again. But how much does all this knowledge that you kind of accumulated and also wrote down, how much do you use it in your daily jobs, or is it more of a passion project?
Almost, I don't use it at all on my job. I in my previous job, so right now I'm working on Datadog, and we are building profiling tools basically, and so I feel like this specific knowledge about the GC is not very useful to me at the moment. But previously I was working still with Christophe in a different company, which was Criteo, which worked on very high throughput, low latency services, and so where performance was very important. And the GC, reducing the overhead of the GC was very important to keep the performance of our services. And so back at Criteo, having the knowledge of the book would have been very, very useful. And actually, that's how we met Konrad, because when we were at Criteo, his book wasn't released yet. And so there was almost no documentation at all on the behavior of the GC. And so what we did is we contacted Maoni Stephens at Microsoft. So she is the GC architect. And we invited her to Paris to teach us about the GC. And when we did so, she told me that somebody was in the middle of writing a book about the GC. And that's how we heard about Konrad, and then we met him at a conference.
Yes, wow. I must jump in with big kudos to Maoni as a lead of .NET. She did a great job reviewing first edition, second edition. She knows everything. She wrote that, so that was super inevitable. Definitely, the book is much better because of her. So thanks, Maoni.
Yeah, I just brought one copy of the book last week, because I was in Redmond last week to discuss with the diagnostic and profiling team, and I was able to give the book to someone to give it to Maoni, so she will get her copy very soon. And just one tiny, because you mentioned that we were able to have Maoni to come to our office, we designed a special T-shirt with cat, because she's a cat person too. So yeah.
Wow.
Yeah, that's the kind of thing, that the kind of attention that we try to express, that we are very happy to get this kind of knowledge with us. But to answer your question, for me, I forgot almost everything that I've learned by writing the book right now. And no. This is a very interesting question, because the question behind the question is do I really need to read the 750 pages of the book to be better at my job? And the answer is obviously not. No, you don't have to do it. We've also worked a lot on providing a good index in the book. So if you have some specific topics and you look at the index, you will find we also added a lot of scenario. I mentioned at the beginning that what we really loved in the book was like the very high level, and then the stuff that goes, but also you have a lot of scenarios corresponding of real life scenarios. And what you can do is just look at the scenarios and see if it fits with what you need in your day-to-day job. And you will learn how to do an investigation. You will see how to better understand what's going on. And I think that's one of the very interesting parts. And it's not only very high level or very, very deep. It's also try to bring brings the information you need at the time that you need. And for my specific case, I'm working, as Kevin mentioned, in the profiling team, and we are working on allocation profiling. And in that context, I pushed a pull request into the .NET runtime, and I work with them to change the way the allocation sampling is working to have a better statistical distribution. And the fact that I worked on the book and I debugged the GC so many times really helped me. But I think I'm the only one on Earth doing this kind of thing. That's not the perfect example, but yeah, it's really helps to understand, to see which tool could be used. That's for me the most important part.
Absolutely. And I guess that you already kind of partly answered my next question, because I was wondering, like Stefan and I, we could always, like, if we have problems with memory management, we could always call you. But who do you call? Who are your teachers and influencers, and where did you learn all of this? I guess, are there any, you already named one source.
Yeah, Ghostbusters, no? That's the
yeah.
Who do you call?
Who are you gonna call?
Ghostbusters.
ChatGPT now.
Yeah, ChatGPT.
Oh no.
No. Again, yeah, I should answer last because I'm the one who is always talking the most. So please, Kevin and Konrad, answer.
I can start. Like for me, like while I was learning it, I mentioned even Sasha Goldstein. I was one of those persons that was definitely I was connected with performance, and a few others people in the community that were writing posts. Like I think the community itself, and some books, but who do we call now? Mostly Maoni, if we really need to, or no one. Like typically it's really hard to find someone that exactly
source code
and diagnostics and investigations.
Really. So, and I'm not kidding. I mean, you can debug the runtime very easily.
Very easily.
Awesome.
So I see you have. So I see that the context of memory management is not that easy, especially when you write a book about the in-depth of it. So, but how do you make? Well, I guess you can't really make it slimmer than 1,000 or 700 pages reducing the font. How do you still approach to make it digestible? And what is your process of writing? How to prepare the content in a digestible fashion for a broader audience?
I would say I'm trying to tell a story. It's really like this is what we want to do, or this is what we want to explain, and these are the different steps and the relation between the steps. So kind of really like a novel. You just explain like this. Give an example. For a book like this, it's more complicated because it's big. The topic itself is big, and we didn't really change the way Konrad built the different chapters with this high-level view. Let's say we want to do something simple. This is how we would do. It's like fit in a page, so it's easy to understand. And then, oh, by the way, when I say we do this, it takes 2 more pages and stuff like this. And at the end, after I think it's chapter 5, but before chapter 4, as I said, every single piece of software is code updating data structure. So we spend some time showing the data structure, and personally, this has really helped me. I need to see the data structure, and I've spent a lot of time understanding the data structure. Once you have the data structure, then it's easy to explain the relation between the different parts of the data structure. It makes sense.
Fair enough.
So now the 3 of you, well, first initiated Konrad, but then Christophe and Christophe and Kevin chimed in and revised the book and provided even more content. What are your lessons and takeaways that you will apply, or pitfalls you avoid applying for a potential third edition?
I love to have some good tool to collaborate on writing such a book. We don't have. It's one of the ideas I had for a startup, by the way. So it's a pity I didn't manage to make it working before we start to work on this. This is something that is really not like, okay, there are some tools, but it is a few hundred pages, a lot of content, and work on it, discussions, changes, formatting, collaboration. It's really hard. We ended up in this saddest solution, like folder with version 2, version 2, version 3 on OneDrive or anything else. And the good tooling for such a collaboration would be definitely something that helps.
Yeah, and I would add that the book editing model is completely outdated. The problem is that, so just for the second edition, we spent 2 years in isolation, and then you get the release, which is basically what agile software development is trying to fix. By the time the book is released, it's already outdated. There are plenty of novelties in .NET 9 that we are not covering. And then people are reading it and they are finding mistakes, because of course we are going to make mistakes in such a big book, and we can't fix it before the third edition. So I think authors really need to switch to a more collaborative model where updates are published in smaller chunks and on the fly. And I know that this is an idea that Konrad has been exploring on its own, and he even created his startup, and I wish something will come out of it.
Yeah, I've been working in the publishing industry for 30 years. Next year will be 30 years, and we need to invent a new model. And I think the way that you've picked, Konrad, is the one that we should be done, which is more collaborative and to deliver on a like a quarter basis or something like this. You can't say, okay, in 1 year, because when you ship the book, it's, as you said, Kevin, already outdated, and it's very hard to keep up, and it's exhausting. It's exhausting. So I think, yeah, more collaborative. That's what you say. But finding a good financial model is complicated.
Yeah.
People are reading less and less books, and I'm sad about that. If I were in my home office, you would see why I'm sad, because I have a lot of books. But things changes. I mean, you have ChatGPT now, which is much smarter than just Google. When you ask Google, or Stack Overflow seems to be almost dead, and it's bad. It's bad because I'm not sure that 100% of the answer that ChatGPT gave me are really valid.
Yeah. Oh.
Okay.
I guess.
So I'm stuck again. I'm stuck again. my conclusion is how to find a good financial way. I don't know. Sorry about that.
Can you just repeat the final part? What is your conclusion?
My conclusion is we need to find a more collaborative way, and the path that Konrad tries to show us is I think the path to go. One of the problem will it be solid enough in terms of revenue? And okay, last but not least, you need to have a real ecosystem. What I mean by that, I mean when we write a blog post or when we write a book, you need to be validated by your peers, by the people that you trust, because you make mistake. You can't see 100% of everything, and that has a price. That has a price to pay, and to be paid.
Fair enough. I guess I have one final question, because a little bit of a jump, but there's each year there's a new .NET version, right? And so does .NET memory management keep changing significantly? Will you have to sort of update the book every year as well with the new versions? And also, like, obviously, how do you see the future? Like, where, what would it look like in 10, 15 years?
I have a very quick answer. I promise
Okay.
I will be very quick. I will be retired in 10 years. It will be your problem.
So it will end with you.
That's my answer. Go ahead, guys.
Lucky you.
I don't think it's going to evolve much because memory management is pretty much a set space. I remember Maoni herself said that everything you can think of to improve a garbage collector is already written in the book somewhere, because there has been a ton of research on the topic. For .NET in particular, I think .NET really needs a low latency GC, and I know that the .NET team wants to build one eventually, but I don't know when it's going to happen. So maybe 10 to 15 years. Let's hope. And then there are all the improvement that the JIT team is trying to bring to avoid allocating on the heap at all. So we are already seeing many of them in the preview of .NET 10, and so try to compute the scope of an object and then allocate it in the stack if it's proven that it can't leave, that is not going to leave the function. So that would be really nice to see.
Those changes are crazy. Like when I'm teaching, giving workshops about memory management, the story was simple always. Like, okay, structs, stack, object heap, and that's it. But now it is unless this and this and that and here, and in fact it always will be on the stack. Because they are really doing a great job in avoiding allocations like that. So even this knowledge about the fact that you should avoid allocations, which is always will be true, they are doing significant amount of work to make it automated and discover scenarios which those allocations may not happen, which is really, really great job. And it makes the .NET really running faster and faster, I think, because this is significant amount of work that can be helping here. And I think that's also moving into the direction when maybe we can say that in 10 to 15 years, the memory management in .NET will be treated as solved problem. So no one will really care. Like we do not care about how TCP works. Obviously, if you are on the very low level of project, probably you care, but in the end, most people even don't know how HTTP work and WebSockets. They have just libraries for that. And if .NET will be, it is definitely pursuing this direction of automated sophistication, I would call. So more and more edge cases will be covered by .NET runtime itself, which is great. Which is less maybe satisfying for nets like us, which like to dive in and say you need to know this because there will be a use case. But maybe these use cases will be narrowing, really narrowing during upcoming days. We don't know.
Thank you so much. We also have a final question from the audience. What is the recommended way to read the book for better understanding? Should we type and run the code, and so on? How would you read the book? I guess it's difficult to answer, but how did you intend the book to be read?
I think that the best way is to try to build your own garbage collector, and then you can return to the book when you have questions.
Yeah.
Write your own book.
What can I say after these very great sentences? No, if you the initial part is still a very high level presentation of the notion of allocation. So if you already know this kind of thing, you can skip these. You can start with, I don't remember if it's chapter 4, where we start to discuss the very notion that are related to .NET itself and the data structure, and then follow the different phases. That would be like maybe 4 to, I don't remember, but the last chapter are more about like optimized code. So if you don't really want to spend some time now to understand how everything works, you can jump to the final part where we give you guidance about how should I update my code for what reason. The tooling session, this is the one that I love. The tooling session is if you want to put in place in your own company or your own team some ways to measure stuff the way you really want, not using the existing tools. So I would pick which one I want to do. That's what I would do. Yeah, don't try to start from page 1 and finish page 750. That's what I've done. It's very, very tiring.
Awesome. And for those,
you can bring in to the beach and you have like special effect on the beach. That's a good idea.
Why not? And for those of us who've already read the book, what are your upcoming projects? What are you going to do next? And where can we see you next?
So maybe I can start. Third edition, no, for now. I have also this .NET Memory Expert course, so it is for people that are more not reading but watching and practicing. So probably I will refresh it along with the content of the book. And Chris, Kevin feel invited already to be mentors in this refreshed version. So it is like, similar content in different form. And that would be probably it, because I'm also slowly some kind of extending my expertise to hot topic like AI. So I will be more and more visible also there. And still being in love with .NET and all that stuff, but exploring different areas. So I'm having a big dopamine hit already because of learning all that funny things like exactly like AI. Obviously, it's unfortunately not super covered by .NET ecosystem, so I even started to use Python, which I was not expecting to do 10 years ago, but it's just a tool, so that's fine. Yeah, and I also love about this my crop-up startup idea. Like, I really believe there is some new way of writing and updating books. Publishing industry should be somehow refreshed. So it's still in my heart, and when I have some free time more, I will come back to this idea also. So and that may be a good model for third edition, because the goal is like making books more like community driven. So there are many people that are also super interested in this topic. Why they should not be allowed to update the book and earn some money from it? So we will see.
Yeah. On my side, in the near future, I will obviously continue working on my .NET garbage collector until I get tired of it, until I get bored of it. The rate of publication of articles is going to slow down for the next 2 months because I'm preparing a talk for a conference. So it's going to be a talk about method calls, because it's something that I discovered actually embarrassingly late, that there is a lot of hidden complexity in method calls. And if you haven't spent time thinking about it, then your mental model about how method calls work is probably wrong in surprising way. And so I'm working on a talk to show that. Yeah, and I can't say much more about it right now, but there's going to be a pretty big change professionally, and there are big challenges coming up, and this is probably going to influence what I'm going to write about in the coming months or years. But I can't say more right now about it, so stay tuned.
But you are not transitioning to Java.
Rust,
No, I'm not.
Rust,
I'm sticking to
Rust.
.NET.
Rust,
Okay. Rust, okay. Rust, okay.
Rust.
Java, no.
Rust.
And for you, Christophe?
I will prepare this session about strings and how to efficiently read strings and build strings and some hidden stuff beyond that. And at Datadog, I'm focusing on memory leak workflow and how to automatically detect memory leak, how to pinpoint the reference chain, stuff like this. I've just finished the profiling the HTTP request, and you have like in the blog post, this is the third one, a monitor HTTP redirect. Everything I'm finding for our own profiler, I'm sharing in a blog post and with the source code. So, and you also have a new CLI tool called .NET HTTP to monitor your own HTTP request. So yeah, continue to investigate ways to help build better application. That's the goal. And yes, AI might be one way to reduce the bar, because usually we say, yeah, we need to raise the bar. Okay, and here the idea is really how to help people to better understand without showing complicated call stacks or graphs or reference chain, or just explaining what's going on. And this is where you need to change. That's my goal for the future. And no book.
No book.
No.
Book freedom.
I want to keep my wife happy. No book.
Fair enough. Yeah.
So the three of you will be at the Premier Update Krakow conference. Do I get that right?
Maybe me. I'm not sure. Not sure. But Kevin and Konrad, yes.
Cool.
Well, Konrad, Christophe, Kevin, thank you so much to the three of you for coming on the show and speaking to us about your wonderful book. And thank you so much for the sacrifices you've made to write this wonderful second edition. And also a huge thank you for all of your community contributions. It's been an absolute pleasure having you here tonight. Thank you so much.
Same. Thank you very much for the invitation.
Thank you.
Thanks.
That was a pleasure.
Thank you, everyone.
Have a nice evening.
That has been amazing. Our stream, we will be back at the 1st of April. Well, the stream will not be a joke, but we will apply some of the knowledge, for example, in the strings that are in the non-GC heap. What if we mess with them? So we will do some shenanigans on the 1st of April.
Wow.
Sure will.
And yeah, with that, thank you very much, gentlemen, for joining this session. Thank you very much to the audience for the lively interaction. And as always, we'll be back.